Hi, my name is Joe Lucibello. I'm a lead data scientist at What If Media Group, and today's talk is Fail Fast, How Efficiency Dominates Data Science. A little background on me. Like I said, I'm currently the lead data scientist at What If Media Group, named to Crane's Fast 50 for 3 years in a row for fastest growing startups in the metropolitan area. We are an interactive advertisement and email list management company. Before that, I was senior manager data scientist at WWE in Stamford, Connecticut. And previous to that, I was the data science manager at ESP. I graduated from University of Connecticut in 2014 with a master's in economics as well. My motivation for today's talk, so this is actually something I'm really interested in. Obviously, we're all here for a data science conference, but I believe that there's many different things around the world of data science that we can do better that would make our impact greater. So specifically, my experience in digital media and advertising has uncovered many externalities that come with expanding data science inside of a company and in the real world. So today's talk will be structured as followed. I'll cover some what I like to call industry secrets of data science, things I've learned all along the way about the glamorous and non-glamorous sides of data science. Like it says here, not all data science is the glamorous apps that we see on LinkedIn. Um, I will also speak about preparing an organization for data science, and what organizations are looking for differs from company to company. I will speak specifically about managing timelines. Um, Specifically, the most effective projects aren't always the ones that make it into production. So that'll be an interesting chat. And I'll talk about evangelizing data science inside a company. How do we allow other groups to participate in testing and modeling, and how that can be the key to getting buy in? So let's chat about some industry secrets, as I call them. So, not all data science is glamorous. I would say about 50% of the data science work in my past has been data cleansing, data manipulation, and data confirmation. So a lot of SQL, and that's a really important skill. It's a querying language that isn't too complex, but it's a manner for data scientists to get data from those who collect the data, whether it be data engineers or people in tech. Um, but realistically, it allows us to be efficient. It allows us to get data quickly and allows us to structure queries so that we can replicate tasks over and over again. Um, some other things that I used a lot in data science, string searching for titles of things to cleanse data, ggplot or matplotlib, whatever your programming preference is, whether it's R or Python. I think you'll be doing a lot of visualizations and checking out what's going on and how you can derive insights and where to start with your data science. And of course, variable creation, something we're all very comfortable with, creating different categorical variables or transformations, things of that sort. The GIF shows my next point, which is that does not look right. The amount of times I said this to myself in the last 5 years is way too high. So that's why plotting things, that's why creating new variables, that's why writing clean and reproducible SQL is very important. You'll hear things like, can we compare it to past reporting? What does this look like last week versus the week last year? Things of that sort. How we can be certain that the data is correct. That's a big part of data science, and that's something that management entrusts data scientists with all the time. So something I want to touch on that's actually really important. When I began my career in private, I believed that every piece of code was supposed to be mine, which when you begin and you talk to people that have been in the industry, you'll quickly realize that that is not the case. Code repurposing is huge, and knowing when to reference others' work or reference your own work saves you so much time. There's been innumerable instances where I've referenced personal projects of mine in the past or things I've learned in jobs past to derive new insights with new data or to build upon to create a larger impact. Keep in mind, Stack Overflow and GitHub are your friend. There are some great members of both the R and Python and the data science community in general that are out there documenting their work, blogging their work. People that detail the how-tos from what they've endured Um, it's a great way to learn. It's also a great way to understand if the direction you're going in is correct. Like I said, you're not expected to remember code from memory, um, but understanding how to get there and the problems that you face and understanding how to tackle those problems is the most important part. Something to keep in mind in your personal development as a data scientist is to be flexible with your tools. Um, you know, Maintain your range and sort of your sharpness by learning as many tools as possible. My current range is R, Python for programming and reproducible work, SQL for getting data, like we spoke about earlier. But also, one of the most important things I learned was data visualizations. They may not help you model, they may not be super insightful to other people. But when creating visualizations before you embark on a modeling journey or an A/B testing journey, you can really understand what direction you want to go in and what things, what variables, what other pieces of data you can link in that are, correlated by just eyeballing. Sometimes figuring out what belongs in a model isn't an exact science. So seeing a picture in Tableau, Chartio, or Looker is a fantastic way to understand all ends of the data. Um, Also, I really recommend up and coming data scientists to learn some Linux. A lot of Amazon EC2 instances or servers in tech or data engineering are Linux servers. And understanding how to execute the code, understanding how to use cron tab, understanding how to navigate a folder structure is really important for helping to meet data engineers or tech in the middle, rather than being so reliant on tech or data engineering to roll out a model. If you understand Linux, you can probably do it yourself and schedule a lot of cron tabs in that manner. I know over the last 6 to 8 months, understanding Linux has allowed our data science team to grow because we are able to schedule things using cron tab. We are able to create reproducible work. And always, everybody, keep learning. You have to stay sharp. You have to stay fit. Technology is always evolving. Data is always evolving. There's always going to be new techniques to code. There's always going to be new tools to maximize your efficiency, to create better models. I know TensorFlow 2.0 was just released a few months ago. That's something I'm trying to learn a little bit more about right now myself. And you just really can't let wins slide because you're not being current. Like, you can continue to read data science blogs, data science newsletters. I know the O'Reilly books are a great way to learn new topics. There's just really a host of resources between blogs, newsletters, books, and GitHub. And there's really no excuse not to stay fit, really. So how do you prepare your organization for data science? One thing you can do right off the bat is set clear goals. So setting clear goals and having everybody understand what is the goal of data science, what is the goal of having a data science department, how this company can use this in order to better themselves. So, letting everybody know that data science is here to use statistics and programming technologies to extract business focused insights. You're here to automate those business focused insights. You're training them to evolve. You're going to distribute these insights so business decisions can be made using them, whether it be automatic or manual. And the end goal is not perfection. The end goal is to increase net profit or revenue. And if you're working for a public company, making an impact that can potentially drive up a stock price. If you're working for a private company, generating more revenue that would drive up your company's valuation. So one great way to help a data science department grow within an organization is establishing a process. So the question of where does the data science department end? What work belongs in the data science department? And where do other departments sort of pick up that work and run with it is a really important question to answer. In all of my previous stops and in my current stop at What If BD Group, it's been important for the data science department to sort of push the envelope because data science touches so many different points of the business. It's important to have that uniformity as an endpoint. So specifically right now, a lot of our work will reside in various tables so people know where to sort of pick up our work from. We do a great job tagging metadata so that we can measure our performance and display it to the rest of the company. One question that, team leaders and data scientists need to ask themselves is an agile development model something necessary? Would sprints help this? Um, can you become more efficient with various different agile models? There's the modern agile model, there's the regular one you'll see here for software development. And really, because data science is a new frontier, the idea of sprints hasn't totally invaded yet. Some companies will use sprints, some companies will not. But using sprints is a fantastic way to sort of shield yourself from short-term distractions and really focus on the long-term design, development, testing, and deployment of models and deployment of A/B tests. So an agile development model is something that could potentially help your data science department. So one process we have internally right now is our current A/B testing setup. It's not perfect. We continue to iterate on it, but I think it does a really great job of preparing teams for what the next steps are with A/B tests. So we'll always start out with clear, realistic goals for our A/B testing and a timeline to sort of understand when we need to cut it off or when we need to change it up. We then determine how this fits in our 3-year overarching plan. If this isn't helping us achieve our future goals, is this really a test worth undertaking right now? We will then create our models for testing. We then store our results in an easily accessible place for the people who run the test to pick up, whether it be some sort of tables, whether it be a Google Doc, whether it be a Google Sheet, an Excel document, just something that we can reproduce automatically where others can pick it up and use. We'll then handle the visualization building to track ongoing performance. This way we have an intimate understanding of how the test is doing and when there's a problem, how we can adjust to fix it or whether we need to cut it off and end it. And then we work with the test runners to communicate those results and suggest next steps. I actually think the latter part is really the most important. Understanding what these results mean for our company is really the most important part. Whether it's a good result or a bad result, you need to know really what this means. And specifically, what I mean by that is scaling. How can the model you just developed at A/B testing be used in your company's long-term plans? Is this test that you ran actually just a one-off that created some revenue short-term, but doesn't actually fit in long-term? Is this just a single instance of that, or is it applicable in many other places? There's many different ways to scale, whether it's driving more volume to a test group or reusing that model and reproducing that test in another instance, whether it be on a site or something of that sort, or a different treatment on your digital product. So there's many different ways to scale. You kind of scale that test horizontally across many different disciplines within your company, or you can scale it up and get more volume to that to generate more revenue. But realistically, suggesting next steps should always include scaling up. The next piece I want to touch on is managing timelines and expectations. So expectations from a department point of view, is your department's goal sort of that overarching academic big picture research idea, or are you producing more tangible impact on a day-to-day basis? Data science departments sort of operate in both worlds, so it's important to understand what your department's goal is. And from a project point of view, understanding what modeling or what A/B testing could marginally add for that project. Is it adding revenue? Is it adding to site experience? Is it adding to long-term stock price? Non-data science peers will value tracking this goal, right? They don't live in our space, but they enjoy, following our testing. They enjoy following our modeling, the idea that data science and their goals can create some sort of synergy that marginally adds benefit in some manner and allowing them to track that is a fantastic way to manage expectations. So speed and efficiency, this is a big one to me. I think actually a lot of data science teams and a lot of data scientists get caught in the world where the work they're doing is fantastic, but they can't make a difference because the insights aren't coming out fast enough. They're not efficient. It's not quick enough for management. And that's not necessarily the data scientist's fault, but it's just the confines we have to work in, especially in digital media where things are rapidly evolving and changing on the fly. Uh, Minimizing turnaround time can make a huge difference in the application of data science. For example, in my current job, we have the ability to apply some light modeling that we can get done in 1 to 2 hours, and really begin a new A/B test the next day. And this allows us to really stay agile and maximize marginal gains. So the model we get out isn't the best. With that being said, it's better than no model, and it gives us a starting point to build and develop more complex models from there. And something to keep in mind, no model is ever perfect. No model is ever complete. We're working with incomplete information all the time, especially if you're modeling human behavior. There's always going to be guesswork. There's always going to be incomplete information. We do our best with creating these models, but it's not going to be perfect. So having a process and capabilities to pivot quickly, that allows the data scientists to maximize their impact. How can they understand where a test is going, a direction it's going, so they can pivot? So my favorite part about my new job right now is one of the core values we have. It's called 80/20 at Wood Media Group. And I love it because as a person with an economics background, marginal benefit, marginal cost played a large role in my life for a very long time. So I'm happy to continue with that. So internally, we'll identify tasks and projects that help us achieve maximum productivity with minimum wasted effort and expense. And we leverage situations where marginal benefit is greater than marginal cost. So what that does is that allows data science the ability to quickly test and cut bait if it's not there. So specifically talking about that light model, we know the 2 or 3 things that always make an impact, but we start with them. And if they generate a small impact, we know we have to do a lot of work. If they generate a big impact, we know the workload is smaller. So then we begin to weigh the marginal cost of improving that model and make decisions over the next days or weeks to determine if this is a project we want to continue. And like I said, like if the project cost is too high from a resource point of view, we reassess our plan. So if that light model is not working out, if one of the bigger models or A/B tests we roll out isn't going that great, we allot ourselves the ability to say, hey, we can continue to spin our wheels, or we can cut bait and use this time and resource and energy to make an impact somewhere else or in a different area of the business. So it's really a fantastic core value we have. And I think a lot of data science teams should think about instituting this in their planning. And finally, evangelizing data science. It's not the data scientist's job to gain fans around the company, but it sure does help to have fans. One great way to get people to buy in is developing the proper visualizations. Developing scoreboards that track goals and metrics and making those dashboards accessible and digestible are really key. There's nothing like rolling out tests or developing models and sort of having them live in production and having people ping you and let you know that your test is doing great and they're really looking forward to this impact over the next week because they're tracking it as well. And that's amazing. Something to keep yourself honest is also to integrate alerts with Slack or email. So R and Python are fantastic at webhooks to push messages to Slack. You can push visualizations, you can push alerts, you can build anomaly detection and have them ping you. So that's a great way to keep people in the loop and let them know when things are going extremely well or when something might be broken. And share your victories with your company. I think too many times in data science, we're on to the next model and we're on to the next big thing. But you should note the times when things are going really well and your team excelled and your team did a great job. So always share those victories. So communication is key. We learned that from a young age. Other departments, people in other departments know statistics, they know computer science maybe, but they don't tie them all together like data scientists. We have the technical precision and the statistical precision. So it's important for us to act as a bridge between those departments and data science. How can we communicate such that data science helps them become more effective as a department? And honestly, it's a two-way street. Listen closely to what they're talking about because you'll hear your next project in there. I would say about 80% of the projects I have out in the wild right now are actually a spawn of conversations I had about pain points and inefficient points with certain processes in other departments. And we say, gee, looks like some natural language processing could help out with this messaging. How can data science get involved and help you become more efficient? How could data science do A/B testing to help you increase net profit in this project? So listen up, and I think not every data science project has to be ground up build. It can start in the middle, and it can start with input from other departments. So why does any of this matter to you? Um, you know, we all have incredible skill and ability to continue to learn complex topics and technologies in data science. That's why we're all here listening. That's why we're all here presenting. Um, but being a part of organizations in the past where not understanding data science in certain situations just causes such a strain and limits impact and limits long-term growth, um, it's just sad and it's tough. So these are just lessons that I've learned along the way, whether it be developing a better process, whether it be developing better communication skills or listening, or developing better visualizations. I think, all of these things in conjunction with each other can create better data science departments and thus happier data scientists. And if anybody has any questions, feel free to find me on LinkedIn. Here's a link, or email me, and we can chat more about being more efficient as data scientists, and being more effective communicators. I'm always open to collaboration, and I'm happy you all joined me for the chat today. So enjoy the rest of the conference. Thank you. A new model, or take that light model and build upon it and generate more impact. And thus lessening the burden on other departments.